Good afternoon. Welcome to the video on section 14.6 and 14.7, which is titled Sum and Difference Identities and Double Angle Identities. So I'm combining two sections here. And this, by the way, is the last video of the year. So I'll try to make this one extra special. Alright, so let's look at these formulas here. There's three new formulas. These are called the sum, and it looks like we got a typo there. That should be not the sun, but sum and difference identities. So these right here, again, are the sum and difference identities. Here's how they work. If you're given two angles, A and B, sine of A plus B will equal sine A times cosine B plus cosine A times sine B. Or sine of A minus B will equal sine A cosine B minus cosine A sine B. Kind of the reverse with cosine. So this is like saying cosine of A minus B equals cosine A cosine B plus sine A sine B. So you kind of go in order. Or if you want to use the positive sign, then you got to use a negative sign on the other side. And then tangent of A plus B would be tangent A plus tangent B over 1 minus tangent A times tangent B. Or tangent A minus B equals tangent A minus tangent B over 1 plus tangent A times tangent B. These will be provided on the final exam. And non-calc and calc sections. So you don't have to worry about memorizing those, because those are a little bit tough to memorize and actually a little bit hard to understand why they work the way they do. So I'll give those to you. The double angle formulas won't be provided, but they're actually not that bad. All you would do is take the sum formulas and substitute A for B. So for example, you could say sine 2A is the same thing as saying sine of A plus A, right? A plus A is 2A. And if you use this formula here and simply replace B with A, you have sine A, cosine A, not cosine B, cosine A, because remember, replacing A with B. So you replace B with A. So B with A, let me actually write that out a little more clearly. Sorry about that. So sine A cosine A plus cosine A sine A. Now if you think about it, sine A cosine A is identical to cosine A times sine A. It's kind of like saying 2 times 3 is the same thing as 3 times 2. So we can express this more compactly as 2 sine A cosine A. So you can just derive these very simply. Now cosine 2A will be cosine of A plus A, which is just going to be cosine A cosine A minus sine A sine A, which is the same thing as saying cosine squared A minus sine squared A. Another way you can express this is replace sine squared with 1 minus cosine squared. We know that to be true from the Pythagorean trig identity. So you could say 2 cosine squared A minus 1. Because if you shoot the minus, you get negative 1 and you get negative cosine squared A, which makes it positive cosine squared A. Or you could replace cosine squared cosine squared with 1 minus sine squared a. So you get 1 minus 2 sine squared a. So there's 3 variations of cosine 2a. And then finally tangent 2a, replace b with a. So we tangent a plus tangent a over 1 minus tangent a times tangent a, which would be 2 tan a over 1 minus tan squared a. If you replace b with a, and using this formula right here. So those are the sum and difference identities as well as double angle identities. So we'll just do 2 examples that utilize these identities, and then we'll get lots of practice with this on block 2 this week, as well as Friday this week. And then, of course, I'm going to give you the final exam review packet on Friday so we can use all of next week for final exam review. All right. So let's look at this example here. Find the exact value of sine negative 165 degrees. So exact value means no decimals. So no calculator. So here's what you can do. Think of 2 angles that can add up or subtract to negative 165 degrees. And your 2 angles should be those used in the unit circle. So take a while to think about this. What 2 angles would you combine to get negative 165? Because if you think about it, we're going to want to utilize this formula to be able to work out example 1. So we want to find 2 angles to plug in for A and B here. 2 angles to plug in for A and B so that I can use this formula. If you said negative 45 degrees plus negative 120 degrees, congratulations. That would work out just fine. So we're going to say this. Sine of negative 45 degrees plus negative 120 degrees will equal the following, where that's A and that's B. And again, I'm using this formula highlighted in yellow. So sine of negative 45 degrees times cosine of negative 120 degrees plus sine of negative 120 degrees times cosine of negative 45 degrees. Or actually, let me do it in the proper order that we have in the formula. Cosine of negative 45 degrees times sine negative 20 degrees. Just so that I don't confuse you guys. Okay? Alright. So, what's sine negative 45? Remember, that's negative 45 degrees. And the units are the following. We have negative root 2 over 2, comma, negative root 2 over 2. Oops, sorry. I meant to put a positive root 2 over 2. So, and then for 120 degrees, there would be negative 120. And those corners would be negative half, comma, negative root 3 over 2. So, okay. So let's work this out. Sine negative 45, you should know, is negative root 2 over 2. Cosine negative 120 will be negative root 3 over 2. Plus cosine negative 45 is root 2 over 2. And sine negative 120, negative 120 degrees should be, oh, oops, sorry about that. Let's see here. That should be negative 1/2. And if you hear any commotion, it's actually my brother's dog who's licking my face right now and going kind of bonkers because he's happy to see me. So this is a little casino right here. Hey, take it easy. All right. Okay, sine negative 120 is negative root 3 over 2. So let me recap that. So sine negative 45 is negative root 2 over 2. Cosine negative 120 is negative half. Cosine negative 45 is positive root 2 over 2. And sine negative 120 is negative root 3 over 2. Okay. So we get negative root 2, or actually positive root 2 over 4 minus root 6 over 4. So you get root 2 minus root 6 all over 4. And that makes sense, because if you're doing sine negative 165, that'll probably be somewhere over here. And we do expect it to be negative, because we're in the third quadrant. You can also check in your calculator to see what the decimal equivalent would be of sine negative 165, and also do the decimal equivalent of root 2 minus root 6 over 4 in your calculator. They will be 100% identical. So we'll do some practice of this during block 2 and Friday this week. Okay, last example. This will be the last example of the year of new material. And then we'll just do practice in class. So cosine A equals 4/5. A is between 0 and pi over 2. Sine B equals negative 15 over 17, with B being 3 pi over 2 and 2 pi. Then find what tangent of A plus B will equal. So what you want to do is draw each of these angles. Okay, so let's work this out. So obviously angle A is in the first quadrant. Remember we drew these triangles a long time ago? So you call that A. That'll be 4, that'll be 5, because adjacent over hypotenuse, and that's 3. And then for the other one, B will be in the fourth quadrant, and that's sine, so it's opposite over opposite over hypotenuse, so negative 15 and 17, and that would be positive 8. Let's now do the formula for tangent A plus B, and then we'll substitute afterwards using the triangles to help us to substitute. So we know the formula is this: tangent A plus tangent B over 1 minus tangent A times tangent B. Okay, and let's make sure I have the right formula, because I sometimes can make mistakes with these. Okay, cool. Casino, no. Stop. Sit down. Stay. Okay. So, hey! Take it easy. So you probably just heard the dog bark. Sorry about that. Anyway, so let's substitute now. So tangent A will be 3/4, because that's opposite over adjacent. Tangent B will be negative 15 over 8. 1 minus tangent A again, which is 3/4, and tangent B, which is negative 15 over 8. And then we just work it out. There'll be 6/8 plus negative 15/8 over 1 minus, that'll be negative 45 over 32. Continue cleaning this up. You should get negative 9/8 up top. Down below, you have minus negative, so it becomes positive. And 1 you could turn to 32 over 32 plus 45 over 32. So in this case, it just becomes fraction arithmetic. So you get negative 9/8 over 77 over 32. Sorry, I'm drawing my 3's horribly. Negative 9/8, flip over the bottom fraction. So you get negative 36 over 77. And if actually we were to try to find angle A and angle B by doing the inverse cosine and inverse sine functions, and then add those two angles and plug it in, you would get the same answer. I'll actually do a calculator demo with you guys during block 2 so we can verify these answers, so you can always check to see if you're doing these right. But the answer would be negative 36 over 77 for that one. And up top, root 2 minus root 6 over 4. So that concludes the video. We're all done. Before I sign off here, just so you know, on Monday, May 28th, 4 to 7 p.m., we'll have a final exam review in my classroom. Snacks and maybe pizza. I probably will be starving, so I might want to get something more in my stomach than snacks. And even more good news. Even more good news. There'll be another review on the day of the final exam. So another review on day of final exam, and that will be from 10 a.m. to 12 p.m. on Tuesday, May 29th. The reason why I can do that is that I don't have to be there for the morning final, since I don't have any classes that are taking the morning final, so I got exempt from proctoring the morning session of the math final exam. I only need to be for the afternoon for you guys. So if you're got any last minute questions you want to ask, I'll be in my classroom on Tuesday as well. Or in case Monday doesn't work, you have another option. So I think you guys will appreciate that. Maybe I'll have bagels. Maybe bagels and donuts. And of course, what are bagels without cream cheese? So I think that's that. I think we're all set here. So it's been fun doing these videos. Maybe I'll teach again next year in a couple years and we can keep having fun with these. But we've reached the end. Okay. So I'll see you guys later this week.